Hey everyone, welcome to Pittsburgh.NET user group. Give us a minute, we'll get started. So we are Pittsburgh.NET group here, and we do have our social handles here if you want to follow us and join the group. And today's topic is second brain powered by kernel memory. We have our presenter Anish. Welcome to the group. Let's start here,
Hello.
Anish.
Hello, everybody. So, can I take over, Balaji, or?
Yeah, please do so.
Okay, so I'm just going to start with presenting my screen, and if you're able to see that, let me know. Okay.
Yeah, sure. I'll
All right. Okay, share the screen. Okay, share screen. Okay, which screen am I? Entire screen. All right. Let me know if you are able to see it.
Yep, we should be good.
All right, so this is not a PPT, it's in Canva, but this was easy to set up. So the idea is that we will not be spending a lot of time today on the PowerPoint diagrams and things like that, but rather we will see a demo of a mini app which I built. I mean, primarily the backend doesn't have a front end, to use kernel memory, which is a AI service actually built by the Microsoft for usage uh, in cases like you have to ingest some documents, remember something, and things like that, right? So what I have built today is a personal assistant sort of a memory thing which can answer questions like if you were to save uh, notes. I do love Evernote, and I was, recently it got sold, and I had some issues with it. And there's like, yeah, what if I just use a little bit of AI to build a note taker, and I can retrieve the notes, not just by the content of the note, but by the context of the note. So, for example, like when I took the note, I was in train. I should be able to ask this note taker, hey, can you get me that idea which I thought about when I was in the subway, right? So those kind of things, that's the idea behind it. And so this this presentation is primarily, we will skip through this really fast, which will show what kernel memory is. So it's an entire AI service. There's a bunch of resources works together to create a RAG pipeline and a retrieval of the information which is ingested by the pipeline with citations. That's the whole idea, right? As we move forward, you will have a better idea of how this works, and then you can come back and think about the slides, what is present in the slides, right? So kernel memory can also be used as a service itself, like you can host it, you can access it through HTTP, and a kernel memory web service, or you can use the kernel memory as a plugin to semantic kernel, which generally for some folks is a natural path because kernel memory is written in C sharp. Using it as a plugin, everything works. But you don't really need to be on C sharp to consume kernel memory. That's why I chose lang graph for today's demo. So you can access it as a service, and you can access it from Python or JavaScript or wherever you're hosting your other application at, right? So all right, so I think I talked about all of this. So this is how its RAG pipeline works. You just give it documents, certain nodes. Today we are going to work with only nodes, not URLs or documents or PDFs. But generally, you can give it PDFs, documents, emails, and even images and videos and things like that. So what it does is it just chunks them, create vectors out of them, store those vectors in some of the vector databases of your choice. It works with a bunch of vector databases, not just Azure AI search. So you chunk them, you store them, and then at a later time when you ask questions to this particular service which stored the information, what it does is it retrieves those informations based on relevance. It may retrieve one or more. And if some question you're asking is already available in memory in several different memories, it brings them up with the different relevances, and then it gives you that back with citations. So that is the idea behind it. So this is how, if you were to deploy it in Azure, but you don't really have to use Azure with the kernel memory. It can work with, for example, instead of Azure AI Search, you can use Pinecone. And for each of these services, instead of OpenAI, you can use Anthropic. It doesn't really matter. You can plug and play. With kernel memory, it doesn't have to be 100% hosted on Azure. So that's one of the beauty of it, right? Also, you don't have to be in C Sharp to use it. So, as I said, you could see there is a document intelligence that's for image and other processing, and there is a OpenAI service, so that's for embedding and retrieval and chat completions. As I said, chunk embed, you need an embedding model, and you for retrieval you need a chat completion model. And I'm also using lang graph today, which also needs which actually determines the user intent to store or retrieve. So I actually reuse the same model I'm using for the kernel memory. So as I said, it works with a lot of things. For storage, you don't really need to stick with Azure AI Search. As I said, you can use other engines, and for OCR, currently only supported through Azure Document Intelligence. That means pictures. You're extracting information from pictures. We are not going to see any of that today, right? So LLMs, it can work with, as you could see, it can work with a bunch of LLMs, like in the bottom of the screen, as you could see it. Hold on. Azure OpenAI, Anthropic, Llama. So when you see your Llama, it means that you can test it locally in a machine without having to deploy it to cloud, and which actually gives me idea of just building a Flutter app and then have Olama deployed, and then your personal memory is not stored on the cloud, just on the device. Okay. So this is my architecture, right? So the kernel memory is there, which is as a service. It's on a specific. Once it's deployed, it's on a specific URL. I hit the URL and its service is up and running. I have wrapped it over an ASP.NET minimal API. The reason behind that is kernel memory has a kernel memory web client class, which you can only use in C Sharp. So for other folks, not all features are available. You have upload method, but you don't have an upload text method. You cannot add tags and things like that. So I wanted to use all of that. So what I did is I internally used kernel memory, and I put a C Sharp wrapper, which is the ASP.NET minimal API, just one file API, just program.cs, just to access kernel memory in a fashion that you were accessing it from C Sharp, right? So this Node.js side is where the LangChain is hosted. And the idea behind this is to use the text coming from the user as a user for user intent detection, right? Sometimes you want to store note, sometimes you want to retrieve note. So for storing note, I may be telling this service that, hey, I have a thought about an event, or I have a thought about an idea about a talk, right? Oh, here is the idea. It's a second brain, and how about I build this, and then I can just say that my thought. No, I did think about it when I was at home or I was at office, and this is the date of the thought, and then send it to it. It will memorize it. Later, I can come back and ask it, hey, what was that thought I had about that talk last week. It will give you, or what are my ideas which I stored last week, or what are my ideas which I stored while I was at the coffee shop, right? That kind of things you can answer, and it will be able to answer that because of the tagging and categorizations and other things. So now, as I said, LangGraph is used for the save retrieval, intent detection, and other things. ASP.NET Core Minimal API is just a wrap around the kernel memory web client. The tagging, time, category, secrecy, I'm like, yeah, this is my startup idea. I don't want this to be public. I want this to be private. Or this is my confidential idea. Or this is my pitch meeting tomorrow. Or, I have to pay a water bill. It's like a private thing, those kind of things. So I'm like, how much is the bill, right? How much was the water? Oh, do I have to pay any bills this week? It should be able to answer all of that. All right. So, okay, now time for a little demo. I will let me just first tell you a little bit about the structure I was talking about. Let me go back. You see this Node.js ASP.NET kernel memory. So this entire kernel memory is a replica of the GitHub repo of kernel memory. Nothing fancy going on in here except that I actually edited the app settings.config to give my I should search my OpenAI instance URL and endpoints and things like that. Beyond that, it is just a replica of the kernel memory. So that actually runs in as a service. As you can see, the kernel memory service is running here. And let me just restart it so you can see that runs here. Right. So this kernel memory service is running at and once it runs, what happens is you can actually hit the Swagger URL and is running at this particular location, right? And this one file actually have a couple of endpoints. As you could see, upload some text. Text is nothing but my notes. And upload some file. We are not going to discuss about file uploads today. I'm primarily focused on just text and things like that, notes and things like that. What did I store, right? That kind of thing. So the ASP.NET Minimal API is just as I said, a single file, and the entire source code is uploaded to GitHub just in case if you want to see it. So now this final outermost layer is the LangGraph Node.js application, right? So this one is pretty all right. So 1 second, let me stop that. All right. So I'm just running this as a node server, right? And the most important files are in the SRC, right? So this kernel memory client is just a JavaScript wrapper I wrote. This one, not the C sharp wrapper. This is actually coming in the same way from C sharp. Method name, you
Hey, sorry about that. I He got disconnected. Just give us a minute. He'll be back. Yeah, here he comes.
Did I lose you
Yeah, we just lost you for a minute.
for a minute?
Anish.
Okay, that's
Yeah,
good. 1 minute is good. I was thinking maybe more. All right. So, what was the last thing you folks heard?
you are in VS Code executing stuff.
Okay, sure. So, the kernel memory client JS is exactly a replica with the same methods as of C Sharp. As that's what I was saying. So, creating tags and index and document IDs and things like that. I will explain about that in a bit. So now this is the lang graph piece. So it runs. See, it runs at this location, right? Location port number 5,000. So what this does is it detects the user intent. So basically, you can see the forget about all the code in here. All you need to care about is towards the end, this lang graph nodes I'm adding, right? So there are three nodes I'm adding: find, detect, indent, gather metadata. So detect intent is to know whether the user wants to save or wants to retrieve memory. That's it, right? That's just two ways to go at it. So think about it like a flowchart. The detect indent just directs either to save memory or to retrieve memory. Now, gather metadata. If you were to retrieve memory or if you were to save memory, for example, I'm saving something saying that, hey, I wanted to read this book someone else recommended. Okay, I was at lunch with him in New York Midtown, right? So now the metadata is New York Midtown and the date and time and the categories and note. It's a public note. It's a learning material. All of that is metadata. That is what the metadata gathering does. Now interact with the KM, this particular node in LangGraph. So I'm not going to explain how LangGraph works. LangGraph works as like a flowchart. Every node you can write code within that. LangGraph comes in two flavors. One is JavaScript and the other is Python. And JavaScript also supports client side. If you were to build only on the client side, it also supports server side. If you were to build only on the server side, you can do that. So now LangGraph is like a flowchart. That's how I understand it. So every piece in the flowchart is a bunch of lines of code which determines where the next part of the tree is, right? So that is how this is what determines that. You say after detecting intent, you go gather the metadata. After gathering the metadata, you talk with kernel memory. Once you talk with kernel memory, finish the job. That's all there is to it. So all we need to know is this. And now each one of these things inside this are individual methods. As you can see, it determines it uses an LLM. Yeah, that's what I said. I also use LLM in the LangGraph side. Uses an LLM whether the user wants to store or retrieve information, right? And then it just goes to gather metadata. As you can see, extracting metadata as categories. Is it an idea I want to note about, or is it a task? Oh, I have to pay a bill or an electric bill tomorrow. Is that what I'm writing about, or is it a meeting? Is it research and things like that? A location, right? So that is the metadata. And once I capture, so this is an example node I'm going to save. So I am giving that example as part of the prompt so that it does know how to create a JSON structure. It creates that metadata. And once it creates that metadata, so the rest of the code is just validation code, just forget about it. And once I have this, I actually interact with the KM. So retrieve is taking the memory out. In order to take the memory out, I am saying that, oh, what did the note I have put in while I was in office? Then it needs to know the metadata too. That's why I'm while taking the note out or while retrieving the note, I need to also find the metadata in here, right? So here, instructing the LLM to retrieve everything in JSON object and things like that. Now, once all of that is done, it is being pushed into the into the kernel memory, right? So either it is been pulled from the kernel memory or been pushed into the kernel memory. It's both done in the same method. So in the if else part, you can see that that's all done in the same method, right? So now, all right, that's about lang graph, lang chain lang graph, right? Lang graph is a new thing came out of lang chain. So our memory is back in service, right? So we can check. One second, I'm gonna grab a couple of things and put it over here. Uh, Let me know if you can see that. All right. Okay, great. So kernel memory actually runs here, right? So this is the URL it is hitting. My minimal API actually hits this. So there are indexes. If you can, if you check it, try it out, execute it, you can find, yeah, this index is where the kernel memory stored all that information. That index is the Azure AI search index. You see that you can see that whatever memory I put in, it actually put that in the AI search. I can actually access and search different things. It kind of, you see all these vectors are coming back. So that is because, as I said, whatever information I said it to save, it is being chunked, vectorized, saved into the vector database. So here it's Azure Search, not Azure AI. Sorry, I misspoke. So Azure Search, it is stored in the Azure AI Search, and then it is retrieved when you ask a question. That's all there is to it. At the end of the day, it's a pretty complex thing behind the scenes. But as a user, I'm a user of kernel memory rather than a builder of it. For me, it's pretty simple that I just give it information and it just retrieves those information, right? If you look at the payload and other things, you can see the text. I'm putting it here. So content.txt, you see the devblocks.microsoft.com. So this is a note I saved with the tag. As you can see, I actually saved this while I was in the train, right? For example, right? So now let's see this in action, right? So this kernel memory service is running. The minimal API is running, very nice. Now the outermost layer, the node service is running. Now let's hit it. Let's hit the node service, which is running on 3000 and try to retrieve some information, right? So I'm going to ask it a question. Okay, before I do that, let me show you what memories I created. So I have a test suite where I created some memories. These are my memories or my notes. I said, save this note. John recommended a book. And where did John recommend it? It's about, well, having coffee. It's at the coffee shop, right? Another note during a lunch. Another note, a startup idea. When did I have the startup idea? All right, that was, where is it? Yeah. So that's in the home office. So if I were to ask this question to this particular service where it stored my different memories, right? What are the startup ideas I noted down? Right. So if I were to ask questions like this, it would answer with those memories. It says an AI assistant that passively captures user context and memories and retrieves them on demand. This concept combines features like LangGraph, kernel memory, and geotag. And there is a second startup idea, a feature allowing users to record voice notes. So there are two items it returned, one and two. Let me show you how that works here. That is actually interesting because it gives a little bit more details of how it picked up those details, right? So see, first it hit the kernel memory, and the kernel memory. Let me how do I just get rid of this copilot? I don't know. All right, so it retrieved that information, right? It picked up this first one, and you see there's a relevant score. So it hit the Azure search service, and it picked this particular text up, and it said that, oh, this may be his startup idea with an 82% chance. This may be another startup idea with a 77% chance. This is the next chance, and things like that, right? And you can see that the tags are coming back too. It said that the location is office, it's a note, it's private, and it's done on so and so date. and things like that, right? So now when you look at the outermost layer, which is the node service, you see this one, this is a startup area, and two is this, right? So now I can ask this different type of questions, right? I can make this a little more interesting. What was that book John recommended? Okay, so I asked this memory some questions like, what did he say? What did he say? I forgot the name of the book. It says The Psychology of Memory by Allen. So he mentioned that it is a must read for designing better AI memory systems. This is not an exact match of the note I saved, but rather a contextual understanding of the note I saved. The note I saved is John recommended a fascinating book, this, and he said it's a must read if I want to design better AI memory. But what it returned is not exactly the same words. This is where the relevance comes into picture. It looked at the note, it understood that, and it actually created an answer for me rather than just repeating what was stored, it which is not possible because it is not stored as a string, but rather as embedded vectors in the database, right? So now I can ask some other questions. I forgot what I saved while I was on train. Can you remind me? So the train is a context. None of the node have train. Train is a tag. Train is something attached to the memory rather than the memory itself. I may have saved a blog. I may have saved something or a note, or probably I was like, hey, I have to pay a bill tomorrow. But the train is the location, which is also a context which gets saved along with the memory. I should be able to retrieve that using tags. So kernel memory has this concept of tags where you can categorize memory, you can put it differently, you can use a tag to, for example, like assign certain memory to certain things, so that, and if you ask, so user one versus user two, you can categorize memory of user one and user two, and they don't get overlapped. And as long as you pass the tags, and it will only pick up the memories of user one and return back to you. So now if I ask these type of questions, okay, it's a little difficult to read here, so I'm going to go back to my console log and show you what it printed. It printed that while you were on the train, you saved the following links. This podcast is part of the learning. And then another one, I saved this link. Kernel memory is now available. It's a dev blog post. And that's part of the category research, right? And saved on another date. This is saved on another date. So these are the type of things you can ask kernel memory. So if you were to, you can even fire some of these notes are private, some of these notes are public. If I simply ask this, do I have any bills due soon? Right. Let's see what it says. Okay, I have a water bill which is overdue and needs to be paid before Friday. You plan to set a notification for Thursday night as a reminder. Right? So now, if I were to, one second, let me pick up some other questions which I asked it before. Okay, some notes are private, like client meetings or pitch meetings or startup ideas and things like that. I say like, what are my private ones or what are my confidential notes and things like that. So if you were to build a front end on top of this is where you actually stop the user from stop the kernel memory from answering the private nodes without providing some type of a validation, right? So you would return back at the line graph level like, oh, he's asking about private nodes. What is the password, or what is your low code? Then you say abracadabra, and then it gives you the private node. I'm just kidding. But these are my private notes. I'm like a new feature idea, had a deep conversations, next Monday's quarterly meeting, some water bills, all private stuff, right? So you get the idea. about how this can be leveraged to multiple levels. The tags are not limited, even though I limited it to certain types for now for the demo. But the tags can have locations, dates, uses, privacies, confidential stuff, and things like that, right? But I'm not going to say that you put your passwords in kernel memory. I wouldn't recommend that. But just in case you have stuff like you want to remember, like an idea to write a blog about, of course you can do that, right? But it's pretty much private note or confidential note for you because it's your note. But it is not as critical as password, so I wouldn't recommend doing any of the password level thingy in putting in memory. So if I were to say, okay, let me ask. All right. I think I covered pretty much all the questions. So I also have a testing of kernel memory question, which is also in JavaScript file. I can just hit it and it asks a bunch of questions. So I generated some test cases, content based, category based, location based questions, time based questions, and things like that. This is also part of the um, you know GitHub repo I created. So these two, this is already, as I said, kernel memory. I'm just using it. I'm a user of it. These two I created, the wrapper and the manager. These are already pushed into GitHub, just in case somebody wants to experiment with it. Um, I can't write any code today. It took a lot of time to build this, and I may expand on it at a later time to include more stuff. But the general idea is to um, this is what I built so far. We already asked that, right? We already asked what did I save. So maybe like you can try stuff like take this code and expand it, like use the tags to like from this date to this date. So you can ask questions like, oh, what was the task, or what are the things I was supposed to do last week, I couldn't do it because work was crazy and they were due last week. It should be able to give you a list back. And maybe real time like models, if you use it, integrate it with some apps like Flutter or React Native, and you can build interesting things with it, and deploy it on the mobile device itself, have a kernel memory on mobile device itself. I don't know how feasible it is, but those are different ideas you can explore further with this. So I kind of ran through the demo really, really quick, and we are only 33 minutes into the presentation. So this couple of QR codes. One is my LinkedIn, and another one is a newsletter I'm building where I'm talking about different things I build with AI. It just launched. Uh, no post or newsletters yet, but I will build publicly with AI using the newsletter. And I have plans to throw my thoughts in there. It's not going to be polished blogs like what you expect and generally read. It's all going to be, you know, the the ifs and buts of building with AI, where you fail, where you crash, what you struggle with, and that kind of things. I will use Cursor AI, Llama Index, LangGraph, Semantic Kernel, and things like that to build applications and mix it with Next.js, React, .NET Aspire, and things like that. That's the idea. So, folks, if you have any questions, this is a good time. And back at you, Balaji.
Am I audible now, Anish?
Yes.
Yeah. I was just saying it's always a pleasure hosting you, Anish. And thanks everyone for joining us. I will see you again next month with another topic. Thanks all for joining us today.
Thank you for having me, Balaji.
Thank you.